Good morning, sir. This is Ashwita from Computer Science and Engineering Department. I am here to give a presentation on BC codes regarding basic electrical and electronics engineering. Outline of my presentation. Introduction to BCD codes, binary to BCD conversion, BCD addition, BCD subtraction, BCD multiplication, division, advantages and disadvantages of BCD codes, application of BCD codes, conclusion. Introduction to BCD codes. BCD stands for Binary Coded Decimal. BCD is a coding scheme used to represent each digit of a decimal number with a 4-bit binary code. BCD codes are widely used in digital systems for accurate representation of decimal numbers. This is the representation of decimal number in BCD code. Binary to BCD conversion. To convert a binary number to BCD, the binary number is split into group of 4 bits. Each group is then converted to each BCD equivalent using a conversion table. The BCD representation of each group is then combined to form the final BCD representation of the decimal number. BCD addition. BCD addition is performed similarly to binary addition, but with addition rules to ensure the correct BCD representation. If the sum of two BCD digits is greater than 9, a correction factor of 6 is added to the sum. Carry propagation is also used to ensure proper BCD addition. Now 5 base decimal to plus 2 decimal is converted to BCD addition through following operations. First, we should write 5 in 4-bit configuration and then 2 in 4-bit configuration. Then by adding those two, we will get the sum of the BCD addition. BCD subtraction. BCD subtraction follows similar principles to binary subtraction with addition rules for BCD representation. If the subtractant is greater than the minute, a correction factor of 6 is added to the difference. Borrow propagation is also used to ensure proper BCD subtraction. BCD multiplication. BCD multiplication is performed using the same principles as binary multiplication but with additional considerations for BCD representation. The product of two BCD digits is a 4-digit BCD number which may require adjustment to maintain the correct BCD format. Carry and border operations are used to ensure accurate BCD multiplication. BCD division. BCD division is carried out using similar methods to binary division with additional rules for BCD representation. The quotient and remainder of BCD division must be adjusted to maintain the correct BCD format. Carry and borrow operations are used to ensure accurate BCD division. This is the binary division. How we'll convert into decimal division and binary division. Advantages of BCD codes. BCD codes provide a more accurate representation of decimal numbers compared to pure binary codes. BCD codes are easier to understand and interpret for human users. BCD codes are commonly used in applications where decimal arithmetic is required. Disadvantages of BCD codes. BCD representation requires more bits to represent a decimal number compared to pure binary representation. BCD arithmetic operations are more complex and require additional logic compared to binary arithmetic. BCD codes are less efficient in terms of storage and processing compared to pure binary codes. Application of BCD codes. BCD codes are used in digital clocks and calculators for accurate timekeeping and arithmetic calculations. BCD codes are utilized in financial systems for accurate representation of currency and monetary values. BCD codes are employed in data encoding and transmission for error detection and correction. Conclusion. BCD codes play a crucial role in digital systems for accurate representation and manipulation of decimal numbers. Understanding BCD codes and their operations is essential for designing and implementing digital systems that require decimal arithmetic. Despite some drawbacks, BCD codes remain a fundamental component of digital technology for handling decimal data. Thank you. This is presented by Ashwita from first year Computer Science and Engineering Department.